Hello students of class 9. Today we will solve the most repeated question, frequently asked question in the final examination of chapter 7 triangle. So keep watch the full video without skipping. Let us start. If the bisector of vertical angle of triangle bisect the base of triangle, then prove that the triangle is isosceles. Let us suppose ABC is a triangle and given that angle bisector of this vertical angle bisect the opposite side. It means these two angles are equal and these two parts are equal. Let us suppose this is D. We have to prove that the triangle is isosceles, means we need to prove that AB equal to AC. So let us write here the given and to prove. So given BD equal to DC, angle BAD equal to CAD. Now to prove, we have to prove that triangle ABC is isosceles, or we can say AB equal to AC. Construction. Extend the AD to DE such that AD equal to DE. We will mention here the construction. Join CE. Now consider these two triangles ADB and CDE. AD equal to DE by construction and BD equal to DC given. And these two angles are vertically opposite angle. Let us angle 1 and 2. Therefore, these two triangles are congruent by SAS. And this, consider this angle 3 and this 4 are equal by CPCT. Corresponding parts of congruent triangle. And also this AB equal to EC. By CPCT. Now focus on the diagram. Listen student, this angle 3 equal to this 4 and these two are already equal given. Therefore this 4 equal to this 5. So 4 equal to 5 base angles. So these two sides are equal by isosceles triangle property. But this side equal to this side. Okay, pay attention, this side equal to this side by CPCT, therefore this equal to this. So therefore ABC is isosceles triangle. Now let us interpret. Vertical angle bisect 3 equal to 5 given. So using these two equalities, 3 is common, 4 equal to 5. Or equal to 5, therefore AC equal to EC. Isosceles triangle, base angles are equal, sides are equal. But AB equal to EC. We just proved AB equal to EC. We just proved. So using these two equalities, AC equal to EC, AB equal to EC. EC is common, therefore AB equal to AC. Hence proved. Next question, ABC is an isosceles triangle with AB equal to AC. Side BA is produced to D such that AB equal to AD. Prove that angle BCD is right angle. ABC is isosceles triangle, BA is produced to D. BA is produced to D such that BA equal to AD. So listen student, ABC is isosceles triangle and BA is produced to D such that BA equal to AD. We need to prove that angle this BCD is right angle. Since these two sides are equal, so this angle 1 equal to this angle 2. Reason we can mention here, AB equal to AC it is given, isosceles triangle. It is given that these two sides are equal and these two sides are equal. Therefore, these two sides will also equal. And these two equalities AB common. So AC equal to AD. AC equal to AD. So we can say this angle 3 equal to angle 4 by isosceles triangle property. Now add these two equations, 1 equal to 2 and 4 equal to 3. 1 plus 4 equal to 2 plus 3. 1 plus 4 means angle B plus angle D. And 2 plus 3 we can say C or we can say BCD. Now in order to get prove this one, let us add the BCD both sides. BCD, this 2 BCD. Now focus, concentrate on the diagram BD, BCD. BD, BCD, angle sum property, it is 180. And it is 2 BCD. Or we can say BCD is equal to 180 upon 2 means 90 degree. So it is proved. Next question, in a parallelogram, if two diagonals are equal, then prove that this parallelogram is a rectangle. So let the parallelogram is ABCD. Given that the diagonals ACBD equal, we need to prove that ABCD is a rectangle. Let us consider a triangle DAB and CBA. AD equal to BC because opposite sides of parallelogram, and this AB and BA common. AC equal to BD, diagonals are equal given in the question. So the triangle DAB CBA congruent, side side side. Therefore these two angles are equal by CPCT. And also the sum of these angles 180 is a property of parallelogram. These are equal, so we can write either of the angle twice is equal to 180. So angle A equal to 90 degree. So this is a sufficient condition. In a parallelogram, if one angle is 90 degree, then it is a rectangle. And it's proved. Next question, ABCD is a square. X and Y are the points on AD and BC such that AY equal to BX. We need to prove that AX equal to BY. Given that ABCD is a square and X and Y points and AY equal to BX. So let us consider the triangle YBA and XAB. And these two triangles, this angle A equal to angle B, right angle of square, AB, BA common, AY equal to BX given, hence triangles are congruent. See, here the common mistake by students, they assume it the SAS. So it is not a SAS. See, try to understand, this is a hypotenuse, this is 90 and this is base. So it is RHS. So by RHS, triangles are congruent. So by CPCT, these two parts are equal. This we needed to prove, hence proved.